we're going to finish up part A of 1.5. Yesterday we talked about the concept of taking the square root of a negative number. That's where we pull the I out. And if you have I squared, what does that value equal? -1, okay? Tomorrow we're going to work problems out using the quadratic formula, but you're going to get a negative underneath the radical. So it's just one extra little thing. So tomorrow should be pretty simple. Today we're going to talk about dividing complex numbers. You have to check the denominators, guys. Whenever you have a denominator of anything, you cannot have a radical, you cannot have an I. So the way that you fix that is you're going to multiply the top and the bottom, but what's called the complex conjugate. All right, we talked about this a little bit yesterday, but the complex conjugate, if I had 2 plus 3i, the complex conjugate has the same numbers, the 2 and the 3i, but what's the sign in the middle? Conjugate, we said yesterday, meant opposite. So what's the sign going to be in the middle? Minus. And the reason why is when we FOIL this, what is 2 times 2? 4. 2 times negative 3i minus 6i. 3i times 2 is plus 6i. And then 3i and negative 3i is minus 9i what? Squared. When you see an I squared, what do? You cross it off and change the sign. Good. So now you have real with real. What is 4 plus 9? 13. And then what happens with negative 6i and positive 6i? They cancel out. See, that's how you get rid of the I. You're going to multiply by the complex conjugate. So we're just going to do a couple of these. All right. How is 19 different from all the rest of them? There's only one thing, right? When there's only one thing in a denominator, all you have to multiply by is the I. You don't have to multiply by anything else other than just the I. So what you do to the bottom of a fraction, you do to the top. So on the bottom, when I multiply 4i times I get what? 4i squared. As soon as I see an I squared, I cross it off and do what? Change the sign in front. So you're left with a -4 on the bottom. You want the i's to cancel out. So it did, so you're good to go. And now we just distribute. What is I times -3? -3i. And then what's I times 5i? Plus 5i squared. As soon as you see an I squared, what do? Cross it off and you change the sign in front. And you always want to write this in standard form, guys. When you write it in standard form, what comes first? The real part or the imaginary part? The real. So it'd be -5 minus 3i over -4. You're going to multiply. Most of the time, you'll see it with two things in the denominator. Yeah.
Why'd you like
because that's a good question. You want to write it in standard form, which is a plus bi. You want the real part to be first, and then the imaginary part to be second. So if I look at this, guys, remember, you have two terms. When you have two terms, put a parenthesis around it because that one is stuck with the I. We want to get rid of the I in the denominator. So you're going to multiply by the complex conjugate. What's the complex conjugate of 1 plus I? Very good. What you do to the bottom, you do where? To the top. I always do the bottom first just to make sure my i's cancel. So when you FOIL this, what's 1 times 1? 1. What's 1 times negative I? Negative I. What's I times 1? Plus I. And what's I times negative I? Negative I squared. When I see that I squared, I cross it off, and I put what in front of it? I change the sign. So what number's there? There's a 1. So what happens with the i's in the middle right here? They cancel, which is exactly what we needed to happen. So when I add the two numbers on the bottom, what do I get? 1 plus 1 is 2. And now I can distribute in the top. What's 4 times 1? 4. What's 4 times negative I? Minus 4i. So you have 4 minus 4i. If you can get that far, that's pretty good. But like with our quadratic formula and stuff like that, we had to see if we could simplify, right? So if I were to separate this to see if I could simplify, you would write 4 over 2 minus 4i over 2. Does 4 over 2 simplify? Yes, to what? 2. Does 4i over 2 simplify? To what? 2i. There you go. So you're always going to do the same thing. We're going to multiply by the complex conjugate, and then we're going to pull apart and see if we can simplify. Let's do 22 and 24. All right, what's the problem? What's the issue? There's an I where? You can have them in the top. Where can you not have them? On the bottom. All right, so how do we get rid of the I on the bottom? We're going to multiply by the complex conjugate of the denominator. What's the complex conjugate of 4 minus 2i? Good, so 4 plus 2i. Because what we want to happen is that the i's cancel. So what you do to the bottom, you do to the top. So let's worry about the bottom first. 4 times 4 is 16. 4 times 2i plus 8i. Negative 2i times 4 is minus 8i. And negative 2i to negative 2i is minus 4i squared. Guys, as soon as you see the I squared, what do? Cross it off, change the sign. What happens with positive 8i and negative 8i? They cancel, perfect. So now we add the numbers on the bottom with 16 plus 4, 20, which we wanted the i's to cancel, and they did, so we know we did it right. So now we go back and just FOIL the top. What's 2 times 4? 8. 2 times 2i plus 4i. 3i times 4, 12i. And then what's 3i times 2i? 6i squared. You see I squared, what do? Cross it off, change that sign in front. So real with real, what's 8 minus 6? 2. And then imaginary with imaginary, what's 4i's plus 12i's? Plus 16i. And then how would I pull this apart to see if it simplifies? 2 over 20 plus 16i over 20. So what does 2 over 20 simplify to? 1 over 10 plus, what's 16 and 20 simplify to? Right? 4 goes into 25 times, and 4 goes into 16i, 4i times. Let's go ahead and do 24, and then we'll go to the last bit, and then we're done. All right, the issue is that there's an I in the denominator. I have to remember that these two terms are stuck together. You can't separate them. So you're going to multiply by the complex conjugate of the denominator. What's the complex conjugate of 4 plus 3i? Good, 4 minus 3i. So what you do to the bottom, we do where? To the top, perfect. Let's go ahead and work on the bottom first, just to make sure our i's cancel out. 4 times 4 is 16. 4 times negative 3i, negative 12i. 3i times 4 is plus 12i. And what's 3i times negative 3i? Minus 9i what? Squared. I see an I squared. I cross it off and change the sign in front. What happens with your negative 12i and your positive 12i? They cancel, which is exactly what we needed to happen. So now I can add 16 plus 9 and get what? 25. Perfect. My I is canceled, which is what we needed to happen. So now let's just FOIL the top. 4 times 4 is 16. 4 times negative 3i, negative 12i. Negative 3i and 4 is negative 12i. And a negative 3i and a negative 3i is plus 9i squared. I see I squared. What do? I cross it off and change what? Just becomes a minus. Good. So real with real. What's 16 minus 9? 7. And imaginary and imaginary. What's a negative 12i and a negative 12i? Negative 24i. Now, I am perfectly fine with you guys leaving the answer like that. WebAssign wants you to split it up. And the reason why is so you get into the habit of splitting it up to see if it simplifies. So in WebAssign, you would put 7 over what? 25 minus 24i over 25. I'm good with this on a test or quiz, but this is for WebAssign. Either way is correct. But it's probably a good idea to get in the habit of splitting it up so you can see if anything simplifies. Okay, all right, next things. To find I raised to any power, okay, there's two different methods. You can divide the exponent by 4, see what the remainder is, or you can use this method of properties of exponents to rewrite. I think the easiest way to do it would be method 1, because then you have some things you have to memorize, but it's not so hard. So let's. What they're talking about is powers of I. We're talking about different powers of I. What is anything, guys, raised to the first power? I'm sorry, anything raised to 0 is 1, okay? If you have I raised to the first power, it's just the letter I. What do we know I squared is? -1, we know that. So in our little pattern, we know anything to 0 power is 1. You know, I to the first power is just I. You see it. I squared is -1, we know that. So I to the third power, you need to memorize, is -I. That's the only thing that you need to memorize. Everything else we know. Anything raised to 0 power is 1. Anything raised to the first power is itself. I squared is -1. So I to the third power is -I. So here is the pattern. If you have I to the fourth power, it's 1. If you have I to the fifth power, it's I. If you have I to the sixth power, it's -1. If you have I to the seventh power, it's -I. I to the eighth power, 1. I to the ninth, I to the 10th, -1. I to the 11th, -I. What do you guys notice about the pattern? Every 4 it changes, right? It goes 1, I, -1, -I. 1, I, -1, -I. So what method number 1 says to do is to divide, right? You're going to divide the power. So you're going to say power divided by 4. Whatever the remainder is becomes the new exponent. So this is really and truly all you have to know right here is that first column. I'll show you how to do this in a second. But you have to know that I to the 0, anything to the 0 power is what number? 1. I to the first power is I. I squared, -1. I to the third, -I. So you're going to see problems like this. I to the 32nd power. Well, what is the process we're going to do? We're going to take our exponent and divide by what? 4, okay? What's 32 divided by 4? 8. What's the remainder? How many are left over? 0. There's 0 remainder. So look back at the chart. That becomes your new exponent. What you're really saying is this is I to the 0 power. What is I to the 0 power? 1. Look at the next one. Your exponent's 33. So take 33 and divide it by 4. How many times does 4 go into 33? 8 whole times. With how many left over? 1. So your new problem that you're evaluating is I to the first power. Well, what is I to the first power? No. Just I, yeah. So take I to the 51st. You're going to take 51 and divide it by 4. How many times does 4 go into 51? Guys, write it out like this. Look. 4 goes into 5 one time, right? Bring down the 1. How many times does 4 go into 11? 2 times. With how many left over? Guys? 3. Okay, remainder of 3. So my new problem actually becomes I to the third power. Look at your little chart. What is I to the third power? It's just -I. Yes. Because there's 4, if you look back at the pattern for I's, there's only 4 choices it could be. It's either going to be 1, I, -1, or -I. Then the pattern repeats. So it's always going to go back to those 4 numbers. What do you guys notice about this one? What does a negative exponent mean I need to do? Put it under a denominator. Perfect. We can't forget our rules here. So this just becomes 1 over I to the 15th power. So take your denominator, or take your exponent and divide it by 4. How many times does 4 go into 15 without going over? 3 times, right? So 3 times 4 is 12. What's 15 minus 12? 3. So that's my new exponent. This is actually 1 over I to the third power. What is the value of I to the third power? Negative I, good. Do you think I can leave my answer like this? Why not? Can't have an I into the denominator, so I'm going to multiply top and bottom by I. Good job, guys. So I get I on top over negative, what's I times I? I squared. So I have an I on top. What is the value of I squared? What's the value of I squared? Negative 1 times a negative gives you what? A positive, just that. The more you practice this, the easier it gets, I promise. How do I rewrite number 11? 1 over I to the 6, good. So now I got to figure out what my new problem is. I'm going to divide 6 by 4. How many times does 4 go into 6? 1 time, with how many left over? 2. Can I simplify that at all? Yep, we know the value of I squared. It's negative 1. So this just becomes negative 1. Cannot forget our exponent rules, guys. Look at number 12. Same base, yes? If my bases are the same, what can I do to the exponents? We add them, good. So 17 plus negative 13 is how much? 4. What does I to the fourth power equal? Look at your little chart. What's I to the fourth power? How many times does 4 go into 4? 1 time with a remainder of what? 0. What's I to the 0 power? Just 1. You're only going to have 4 answer choices, guys. It's either going to be 1, negative 1, I, or negative I. You already know 3 of the 4. I to the 0 power is 1. I to the first power is just I. I squared is negative 1, so we need to remember that I to the third power is negative I.